Hi, everybody. Welcome back to Chem 140. Let me wind this down here. We're doing nostalgia today with more remixed Legend of Zelda stuff. Pineapple on pizza is not gross in my opinion, but there are better toppings. Like, I'm not a huge fan of sweet on my pizza. Like, it's not the pineapple that's the problem, I guess I would say. Like, I would not put, what else would I not put on my pizza? I like my pizza to be savory. Like, I like supreme pizza a lot. Like, I don't like red onion because I think red onion is too sweet. Like, that would not be something that I would want on my pizza. I don't know. That's just what's immediately coming to my mind since we're talking about pizza. Anyway, we left off yesterday talking about ionic compounds and how to name them. I don't think we did these exercises. Would I eat barbecue sauce on a pizza? Not my preference. Barbecue sauce is a little sweet. I do like barbecue sauce though, just not on a pizza. I don't know if I've ever had a breakfast pizza. Anyway, while we're talking about pizza here, which I'll continue in the chat, I want you to name these ionic compounds at the top, and then at the bottom, I've given you the names. I want you to turn those into formulas for me. While you're doing that, let me go over the agenda items for today. So, lab worksheet number 3 is due tonight. It closes tomorrow. Make sure you get that in by the deadline. And then quiz number 5, I forgot to put the quiz up yesterday. So I'm going to do that after class today because I have a note on my desk that literally is just this giant piece of paper. This is put quizzes online. And if I don't do it, I can't remove the paper. And I hate having extraneous stuff on my desk. So we'll get that done after class today, but that'll be due next week. All right, go ahead and name these. I'm going to hit the mute button and then I don't know, address these pressing pizza questions, I guess. So I'll see you in about 4 or 5 minutes, we'll say. All right, what I'm going to do is, if you need these problems still, go ahead and pause the video, but I'm going to give you the next page of them. I'm going to give you 5 more minutes to finish these, and then we're going to go over all the answers together. All right, 1 more minute. We'll go over the answers here. All right, sorry about that. I said 1 more minute, and then the cat came up again to harass me, and I was like, oh, I was going to check to see if I'd fed them. And I did feed them, so they're just being a pain for the sake of being a pain. All right, so let's write out the names of these. Why can I not? Oh, there it is. Okay. All right, so Li is lithium, and O is oxide in an ionic compound. So we're going to name the metal, and then name the nonmetal with "ide." Remember, be careful about spelling. All right. Depending on the periodic table that you're using, you may see an extra I in aluminum. I'm going to just stick it right there, aluminium. So if you are British, and you spell it with the extra I have programmed Canvas to accept that. So that is an acceptable typo because it's not really a typo. It's just the British spelling of aluminum. It's aluminium. Same with sulfur. If you spell sulfur with a PH, it should accept it. If it doesn't, let me know, and I can edit that for you. And then this down here is potassium iodide. Then we got strontium, which is this, and bromide, which is that. So you could put those together to get this as your formula. By now, we should know how to make ionic compounds. So it's just a matter of interpreting what the words mean, right? So this is sodium, and this is sulfide. And then magnesium, and then iodide. And there you go. So that's page 1. Page 2 is a little bit, well, it's not really more difficult because I'm not making you turn them into formulas. We're just writing the ions at the bottom and combining these. So formula would be COBr3, just to combine those, which would be, since this is cobalt with a 3 charge, cobalt 3, bromide. There we go. For our ionic compound for titanium and oxide, we could put 2 oxygen or 2 oxide ions together. Titanium is 4 plus here, so we got to indicate that. Titanium, 4 oxide. There you go. For my chromium 2 and my sulfide, I just stick them together because they're both 2, right? And then this would be chromium 2, sulfide. And then down here, all I have to do is make the ions. So gold 1 would be that, and then chloride would be that. Sodium is this, and nitride is this. Barium is that, and oxide is that. And then platinum 4 is this, and fluoride is that. And you could put these together if you want to make ionic compounds. Just as practice, that's fine. All right, that's naming ionic compounds. We have one last thing to do with it, which is to name polyatomic ionic compounds, and the only change that we're going to make here is that you just take the name of your polyatomic ion and drop it in the box, and you don't make any further changes to it. So if a polyatomic ion is shown, drop it in the appropriate box. Don't change it in any way. So if you have ammonium, all you do is just drop ammonium into where it says name the metal. If you have chlorate, you just drop that into name the nonmetal with ide. You do not adjust it in any way. It's already been adjusted for you. Unit 6 has all the polyatomic ions, which means that you will have to either go back to the Unit 6 video or access the Unit 6 slides, because they're all listed there. If you have not memorized them, again, online class, probably not worth memorizing, but a long-term goal should be to learn them. All right, so this is going to require you to have these available. So if I say, what is this? This is not going to help you in any way if you don't have these handy. So literally, all I'm doing is just dropping the word permanganate because I have permanganate in here. This is bisulfate, so I just drop it in there. So while you are getting those ions handy, I'm going to put these on the screen for you. Let's just do these for now. So go ahead and go find those slides that have those on there. And I want you to try and name these up at the top here and then write a formula for the ones at the bottom. Do the best that you can in the chat. And I'll give you 5 minutes to do this, and then I'll put the next ones on the screen, and we can do those too. And then we'll be done with ionic compounds. Hooray. All right, I'll see you in a bit. One more minute on these, and then I'll put the next set up. All right, pause the video if you need more time on this one. I'm going to advance this to the next slide here. And I'm going to give you 2 or 3 minutes to do these. These are just the same as the previous slide, bottom section, except I've thrown in some transition metals just to make things more interesting. So try these, and we'll go over all the answers in about 3 minutes. All right, 1 more minute. All right, let's go over the answers here. So we'll go back to this page. And where is my stylus? There it is. Okay. All right, so the real key to naming these is, I didn't mean for that to disappear there, is knowing what the polyatomic ions are. So first you got to be able to identify them, but then you got to know what they actually are. And you got to look them up. So this first one, NH4 is ammonium, and then SO4 is sulfate. And those have charges on them too, and those charges have already been taken care of with these formula subscripts. So this one in particular. When in doubt, break everything into ions, and then you can just match them to the table. So there's potassium chlorate. This is carbonate, so this will be barium carbonate. And then we've got lithium, and then Cr2O7 with a 2- charge is dichromate. Then down here we've got sodium hydrogen carbonate. So I'm going to put sodium for that, and then hydrogen carbonate is this. And I could just combine those together. I got ammonium and nitrite. So that would be NH4NO2. Don't need parentheses because I only had one of each ion. If I had multiple of one of them, I would need parentheses for that one. And then I have potassium phosphate. So that's K3PO4. So there's that page. Give you a second to copy this down if you need it. You can pause the video as well. And then we'll go to this page. Same process here. Calcium and then sulfate. I can put those together. I only need one of each. I got rubidium and hydroxide. And I got nickel 2 and cyanide. So I need at least 2 of the cyanide ions because I got to balance out that +2 charge on nickel. And then molybdenum with a 6+ for the 6 right here. And phosphate is this. So I need 2 of the phosphate, so I get MoPO4 2. There you go. So be careful with parentheses. I'm looking over the answers. It looks like most people got most of these right, so that's good. Just issues with trying to find the right polyatomic ion, most likely. So be mindful of that. Make sure that you know what the polyatomic ion is and its charge, because that is necessary for figuring out its formula. All right, that's it for ionic compounds. These are just more examples that talk about, like, use parentheses if you have to. So I'm going to skip over these. We're going to go over to naming molecular compounds. So you can do these exercises on your own if you'd like. All right, what you need to do is you need to draw a line on your note paper or whatever it is that you're doing and mentally compartmentalize these notes to be separate from the ionic compounds rules, because you're going to notice that when I put this on the screen, wow, that looks awful similar, doesn't it? All there is a little pound symbol in the front, or a hashtag, I guess it's called nowadays. Oh, excuse me. Sorry, big yawn there. So, these compounds follow a totally different set of rules, but they look real similar, so you gotta be careful with this. So the first thing you're going to do is you have to identify which element is the first element. Now, I've written the word electronegativity on the slide without realizing that we don't really do electronegativity in Chem 140, so you don't know what that term means. Instead, what we're going to do is we are going to say that it is the more positive element, or in other words, more metallic. That one goes first. Now, none of these are actually going to be metals because we're only using non-metals here. But remember how the periodic table is arranged. Metallic character increases as you go to the left or down. So you're going to pick the element that's the furthest left and down to go first. Oh, excuse me. Now, in the boxes at the front here, you can see that I have attached to the name itself a little box that has a number symbol in it. And what that means is that when you have a given number of atoms of that element, you're going to add a numeric prefix for how many atoms there are. So if you had 2 or 3 or 4 carbons, you would say di, tri, or tetra, and then you'd write carbon. All one word. So these numeric prefixes are only used for covalent compounds. Just like how Roman numerals are only for metals in ionic compounds, numeric prefixes are only for covalent compounds. So be careful. There are the prefixes on the screen. Where it says one sometimes omitted, we're going to, I think that's right here. So if the first element that is in your formula only has one, then you don't use mono. You just ignore it. So, for instance, we do not say monocarbon dioxide for CO2. We just say carbon dioxide. But if it was C2O2, we would say dicarbon dioxide. So we only do this with mono. Mono only appears if it is in the second element. So, like, CO would be carbon monoxide. We do keep mono for that. Now, if you end up with a situation where the end of your prefix has like an A or an O, and you're next to oxygen, for example, and you get a double vowel combination, we end up dropping this character that I'm highlighting just to make it sound better. This is important to know because, again, Canvas is going to be very strict on typos and stuff like that. So you want to make sure that you know that you don't write pentaoxide. You want to write pentoxide. Or octoxide, not octaoxide. So that first vowel in the two vowel combination for AO or OO gets discarded. Note that with di and tri, we do not drop any vowels. So trioxide is correct. It's not trioxide like it were, I don't know, French or Italian, I guess. And finally, no Roman numerals in these. Never Roman numeral. All right, let's do some examples. I want you to try and tell me what the name of this is and type it in the chat. All right, let's go over the answer here. That's the highlighter. I don't want the highlighter to be red. That would be bad. All right, so I've got 2 nitrogens. So I need to add a prefix for 2 in front of that. And so that's di. And I have 5 oxygens, which we're going to write oxide for. But I got to put a prefix for how many? So 5 is penta. But I have an AO combination, so I want to say pentoxide. So there you go. Very good. How about this one? What would I call this? I'm muted. I'm just sitting here talking. Sorry. So very good. Sulfur dioxide. What is this? But you can't call it water. It's not water anymore, right? All right, so there's 2 hydrogens, so that's dihydrogen. There's 1 oxygen, so that's monoxide. So we are all set there. Now, H2O is kind of weird. Remember that H2O is not defined as an acid, even though it starts with H? Water is technically the limit of what something can be and be acidic, but it's also true for that for bases. It's actually the midpoint. Water is the weakest possible acid and the weakest possible base. It's effectively neutral. So we name it like a covalent compound because it technically does both, but 99.9999999% of all water molecules remain water. So we just treat them that way. All right. Now, this naming scheme brings up an interesting and funny little aside, which we're going to do before we take our break here. And that is this. How many people have heard of the petition to ban the notorious chemical known as DHMO, or dihydrogen monoxide? This is a real thing. And we're going to talk about a little bit of this at the end. But first, let me discuss all of the consequences of dihydrogen monoxide exposure and environmental impacts and stuff like that. So the first one is that dihydrogen monoxide has a common name known as hydroxyl acid, and it is the major component of acid rain. Not only that, it's a major contributor to the greenhouse effect. So carbon dioxide is a bad greenhouse gas, but dihydrogen monoxide is so greenhouse intensive that it can trap heat extremely effectively. And it's just everywhere. We just don't care, I guess. I don't know. It can cause severe burns if you're exposed to it, and if you breathe it, you will die. These are all true facts about dihydrogen monoxide. If you have too much of it in a given place in the environment, it will cause erosion. So the landscape will greatly deteriorate by repeated exposure to this compound. It also accelerates corrosion and rust. It can cause your brakes to fail on your vehicle, and it can cause electrical shortages or outages. And every single person who has died from cancer has this in their body. It's been detected in every single person's body who has died from cancer. And despite all of these terrible things, dihydrogen monoxide is still used today. It's used in industry and as a coolant. It's used in nuclear power. It's used in styrofoam. It's used to put out fires. It's used in animal research in cruel and unusual ways. It's even used in pesticides. You can wash your produce all you want, and it's still contaminated with dihydrogen monoxide. It's in junk food. It's in other foods. It's everywhere. Oh, it's everywhere. And why is it everywhere? Because it's fucking water. Right? Yeah, it's everywhere. Water's everywhere. Yeah, you'll drown if you breathe water. Don't do that. Yeah, if you wash produce, it will still be contaminated with dihydrogen monoxide. Of course it will, right? But the point of this, and actually kind of the point of the whole nomenclature chapter, is that all of these chemicals that we've been working with, let me just get dihydrogen monoxide off the screen here. Like, they sound kind of awful, right? They sound chemically and scary. Ooh. And in fact, if you flip over any food package, you will see chemically sounding names. Well, guess what? A chemical is literally anything. Everything that can react with something else is a chemical. So if somebody says, I want a chemical-free diet, tell them that you hope that they enjoy starving to death, because food is chemicals, right? So the point of nomenclature is that we need a systematic method in order to name things properly so that we can identify them. But at the same time, we have to develop an sort of acceptance and understanding that, yeah, this is the way that we have decided to do this. Don't be afraid of chemically sounding names, because this one in particular, dihydrogen monoxide, is essential. You do need this. Don't swear off water. You're going to feed and drink off the energy of the universe. That's a very metaphysical idea. Let me know how that works out for you. The Chemistry 60 no chemical chemistry set. Is it just blank? Is it an empty box? I would like that. Now, as another joke, the petition to ban dihydrogen monoxide was actually brought up in two separate places. One of these was Australia. The other was Florida. I'm going to let you guess which one is which. All right, scenario 1. Brought before the Senate of the country/state, so I don't give away which one, with these points, and it was voted upon to ban dihydrogen monoxide, and the vote either passed or before the vote was held, everybody had a good laugh about it and said, ha ha ha, we almost banned water. This highlights the need for chemical awareness and chemistry education. So they had a good laugh and it was educational. They did not actually ban water. That was scenario 1. Scenario 2, a radio station as an April Fool's Day prank said, hey, have you heard of this substance called dihydrogen monoxide? Yeah, it's in your drinking water and it causes all these problems. And they listed off all of these things. Mass panic within an hour. Thousands upon thousands of people called into this radio station in a extreme frenzy. The station was taken off the air, and those hosts were banned for like 2 or 3 days, I believe. Like, I think they were supposed to be banned permanently, and then people were like, no, you know what? People are just stupid. All right, you be the judge. Which one's Australia, and which one is Florida? I'll leave that as an exercise to the reader. We're going to do these examples when we come back from the break. But for now, what we're going to do is we're going to listen to more Zelda. All right, let me hit play on here, and we'll see you in just a little bit. are a bunch of molecular compound formulas. I want you to turn those into names. And then at the bottom, I want you to turn those names into formulas. That one's actually pretty easy to do at the bottom, so there's only 3 examples there. Go ahead and do these, and we'll go over the answers, and then we'll talk about acids in just a bit, and then we're done. So we're probably going to finish a little early today. All right, 1 more minute. We'll go over the answers. All right, I'm back. Just chatting in the chat here about Iowa, of all places. There are 2 places in Iowa that I would recommend that everybody go eat, and I wish I knew what they were, like their names, or even where one of them is. So there is a place on the Mississippi River that I was typing in the chat. It's in Clinton, Iowa, because I was visiting people who lived in Clinton. And it's this place that's on it's right on the river. Um, it's like on an overlook over the water, and they serve something called Chicken George, which is basically just breaded chicken in a special sauce. It's fan-fucking-tastic. It's so good. Like, I would just drive over there for that, going across the country. Like, I have to stop here because I have to get this food. The second place that I would recommend, and I don't know where this is because another friend who lived in Iowa took a bunch of us there. You like drive down like 74 dirt roads into the absolute wilderness, and it's this restaurant that serves breaded catfish, and it's incredible. I don't even like fish. Like, they're like, oh, we're gonna go get seafood, and I'm like, oh, all right, well, I guess I'll go. And then I tried it, and it was just like, oh my god, this is so good. And I have no idea where it is. I could easily ask about it. I might get that information. Poke me on Discord, and I'll find these places for you. You'll not see me driving to Iowa because I don't have a connection to the internet while driving. I don't know. It'd be hard to stream. All right. Do you capitalize covalent compound names? Nope. So all names follow the same rules for that we had on the warnings yesterday. So no capitals. The reason that these are capitalized down here is because of just how Microsoft works. It tries to capitalize the first thing. And I guess I got sick of trying to edit it. Like, you type something and it automatically capitalizes it for you. So these should not be capitalized. So I'll just put a lowercase one there. So yeah, no capitalizing names because they're not proper names. All right, so let's name these. So I've got 2 nitrogens. That's apparently dihydrogen. Like, I just dropped 2 letters. I don't know what's going on now. Let's pretend that didn't happen. Dinitrogen. And then monoxide. There you go. And then we've got dichlorine trioxide. Now, you mentioned that there's a stream of me eating at the restaurant while helping students. When we were on campus, I'm just going to write the answers while I tell you this story. Next to the campus is a really good taqueria called Taco Book. And I always would tell my students, like, I go to Taco Book, and if you have questions, like, right after this class period or whatever, and you want, like, an open office hours, if you see me at Taco Book, I'm happy to answer questions while I eat tacos. And one particular quarter, that became, like, a thing that people did. Like, of the 24 students, like, 7 would go over to Taco Book, and then we just sit around table and answer, like, lab questions and stuff, so... So tetraphosphorus. We're going to pretend that didn't happen. Dec oxide. Isn't oxygen more metallic and would be listed first? So with chlorine and oxygen, they're actually kind of diagonal. They're diagonal from each other. So one is further left, but the other one's further down. Going down is more of an impact than going left does because there are less spaces to go down. So chlorine ends up being more metallic. That one's kind of weird, I understand. Later on in 161, we're going to talk about electronegativity, and we're going to learn that oxygen only goes second unless it's paired with fluorine. Then it goes first. So oxygen is always the second element unless your second element is fluorine. And yes, sulfur hexafluoride is the voice-lowering gas because it's more dense than air. And when you breathe it in, you get a real low voice like this that I can't really simulate very well. Let me see here. Okay, I think I answered all the questions. Okay. Diboron would be that, and then trioxide would be that. Carbon disulfide, so there's carbon disulfide, and then oxygen difluoride. Oh, there's my oxygen goes on the front. The only compound for binary covalent compounds that we're going to have where oxygen is the first element is OF2. Every other compound, the other element would go first because oxygen is very electronegative. All right, so that's covalent compounds. That's it for that section. So make sure you keep the ionic and the molecular rules separate. Acids are unique enough that the trick really ends up just being like trying to memorize those. So let's do that, and then we're all done. So as we defined on Monday, an acid has H plus in it. The other thing is just whatever the other anion ends up being. So that's whatever it's paired with. I'm going to use the generic anion A because I'm Canadian. If I could click on this, there we go. So if this is my acid, it would dissociate into H plus and A minus, whatever A ends up being. Now, depending on the charge on the anion, you're going to have enough H pluses to completely neutralize it. So, for instance, in HCl, the ion that forms for chloride is Cl minus. So I only need one H plus. But for phosphate, it's 3 minus. So I need 3 of them to cancel that out. So all acids behave in this way. And they can all dissociate all the way down to there are no H's left, because H can just pop off whenever it wants to. Now, there are a bunch of rules, and the nomenclature rules depend on the state that is involved. For our purposes, if the state is not mentioned, assume aqueous, because that is the more common form of the acid. However, if the problem specifically says, name this if it was in the gaseous state, then you would follow the gaseous state rules. And here are those rules. So, rule number 1, you're only going to fall into one of these rules. So, you're either going to be 1, 2, or 3. And there are some subsets for these rules that we're going to go over in a second. So, if you are a binary acid, then it contains H and some other element as an anion. So, that could be F, Cl, S, Se, Br, I, etc. And those will all have a charge on them, -1 or -2 or whatever it ends up being. If your binary acid is in the gas state, this is the name that you use. You write the word hydrogen, and then you write the name of the anion with "ide" on it. So HCl as a gas would be hydrogen chloride. Yes, that is exactly the same as the covalent rules. The more common way that you're going to name this is to use the aqueous state. So HCl as a aqueous solution, so that is dissolved in water, not just HCl dry gas, would be hydro, whatever the stem is without ide on it, ic acid. So this is my stem. We would get rid of the ide there. And I would write hydro chlor for my stem, ic acid. And there is a space between ic and acid. There are no other spaces, though. Now, there's one other acid that does follow this rule. HCN follows this algorithm, and you get a hydrocyanic acid from it. Really, the rule that we want to follow, but this isn't in your text, is, hey, if your anion ends in ide, which is going to be all of your element ones, or cyanide, it follows this pattern. You chop off the ide and just write the name as hydroblankic acid. So that's rule number one. Rule number one is the only one that matters about phase. The rest of them don't. And again, we're only really going to see the aqueous state more often than not. All right, so here's some examples. I have included the phases because in this case it is important. I want you to type their names in the chat, or I'm going to do this. 1, 2, 3, 4. Give you 2 minutes to do that. All right. So for the two gases at the top, you would name them hydrogen whatever it is. So hydrogen bromide and hydrogen fluoride. And then the bottom two, since they're aqueous, you would have hydro whatever ic acid. So that would be hydrobromic acid and hydrofluoric acid. And that would look like these. All right, that was rule number one. Let's look at rule number two. Rule number two, and also rule number three, are for oxyacids. An oxyacid has some polyatomic ion in it, and one of the elements in that ion is oxygen. You'll notice that in the polyatomic ions list, there are tons and tons and tons of polyatomic ions, and they're all derivatives of oxygen, right? Like they have 2, 3, or 4 oxygens in them, maybe 1 in some cases. And they all have similar sounding names, and all of the names end in one of these prefixes, ate or ite. And so what you do is if you have an acid where the ion is the polyatomic ion that ends in ate, you chop off ate and you replace it with ic acid. So something like sulfate, which is this, would become sulfuric acid H2SO4. Now, this extra we're going to talk about in a second here. But you can see how I'm getting rid of the ending, and I'm attaching a new ending of my own. If you have an ion that ends in ite, instead of writing ite, you write us acid. So something like nitrite would become, we get rid of this, nitrous acid, which would be HNO2. And those are the acid rules. That's all 3 of them. So you either have something that ends in ide, ate, or ite. All right, so here's an example. What is this? You got to go look up what this polyatomic ion is, find out what it ends in, and then give me the name. I'll give you a minute to do that. All right, let's go over the answer here. So this is this ion right here, which is called acetate. So if I get rid of the 8 part, I can call this acetic acid. Boop, there you go. No hydro on this one, because it is not a binary acid. How about this acid? We already did that one, sorry. How about this? How about these acids? Now, when we work with sulfur or phosphorus, when you get rid of the stem on this, you add extra letters just to make it sound better. So instead of sulfite becoming just sulf, we put this on there. So this would become sulfurous acid, would be H2SO3. And then this is phosphate. Instead of saying phosp, we write phosphor. This would be phosphoric acid. All right, last set of exercises here on the screen. I want you to name these acids at the top, and then at the bottom, write the formulas for them. So this is going to require your polyatomic ions list, because a lot of these are polyatomic ions. Do I have more of these after this slide? I think that this is it. No, this is the last slide. Okay. So go ahead and try these. I'll give you like 6 or 7 minutes. We'll go over the answers, and then we're done. Whoops, sorry about that. I didn't mean to advance the slide there. I'm trying to browse a web page, and then I guess as soon as I move my mouse over, I try and scroll, it screws it up. So let's do 2 more minutes, and we'll go over the answers. All right, let's go over the answers here. Oops. I don't know what PowerPoint does on the best of days here. All right, so this right here, ClO4, is perchlorate, which we're going to chop off the 8, and it will become perchloric acid. All right, this is hypobromite. We'll get rid of the ite, and this becomes hypo, which you do include, bromous acid. This is dichromate. Get rid of that on the end. Becomes dichromic acid. HCN, remember we're assuming that these are all aqueous. So this is cyanide, so it becomes hydrocyanic acid. That's the weird exception from before. My ear is itching now. Sorry. This is phosphite. And so this becomes, get rid of this. This becomes phosphorus acid. There you go. Be very careful about this right here, this OU, because phosphorus, the element, does not have an O there. It's just PHOS, PHORUS is the element, but adding the extra O makes it the correct spelling for this acid. That's a real common typo that people make, so. And then down here, sulfuric acid would be, so ic would be an 8, so this is sulfate. SO4 2 minus. And so that acid would be H2SO4. Nitric acid would be nitrate, which is NO3 minus. That would be HNO3. Chromic acid would be chrome 8, which is this. So that becomes that H2CrO4. Hypochlorous acid becomes hypochlorite, which is this ClO minus. And then periodic acid, or periodic acid, which is what it's actually called, is periodate which is IO4 minus, which becomes that. So be careful about periodic acid. It looks like periodic acid, and you're like, what the heck? That's not any of the things. It totally is. It's periodate. All right, that's all I got. That's all we got for Chapter 11, too, so woohoo. All right. And that's it for naming. So we're not going to do Unit 12 today. We're going to start that next week. There is a quiz on Unit 11, so there's going to be 2 quizzes due next week for this class. Quiz number 5, which is Units 9 and 10. That'll be due Monday, closes on Tuesday. And then the Unit 11 quiz on naming will be due Tuesday, closes Wednesday. Things to note about next week. Next week, there is a federal holiday on Monday, President's Day, which we observe because the college is a public institution. So we will not have class on Monday. Instead, next week, classes will be Tuesday and Wednesday. So just a heads up, don't show up for lecture on Monday because I won't be here. But I will get the quizzes posted in just a little bit. I'm going to go get some food very briefly and then sit down and do some more work. But that's all I've got for this week. We'll take it a little bit easy as we go to the weekend. Take 15 minutes off of the class, whatever. We're on schedule, so I don't feel bad stopping class early. Again, thanks for participating in the lecture. It's nice to see a bunch of people chatting, even if all we did was spend most of our time talking about pizza. Like, that's fine. I like talking with you guys. Take care. Have a wonderful weekend. Get those quizzes done. Get that lab in tonight. And we'll see you next week.